Hello, Tuesday chemistry class. It's Frank and
Dan.
you know that we just survived a chemistry exam, so hopefully everybody did good. You all studied because we had that 4-day extension, remember? So anyway, over the next 5 to 10 minutes, we're going to be taking you through the process of melting aluminum and smelting aluminum 101, which does involve the calculations
Of how much energy it would take to actually achieve this.
Yes, so let's get started.
Our goal is, of course, to go from the solid state here across the energy it would take to actually melt the solid aluminum. And then we will go slightly into this, but unfortunately, since we are chemistry students and poor sport, we do not have the tools to measure the temperature of molten aluminum, so we will stop our calculations here.
And then what would occur after we have reached this point?
It would keep going up, and eventually we would reach a point where the aluminum, the molten aluminum, would start to convert into gas. Obviously, we don't have the tools to reach it that hot, which is probably a good thing, because then we would probably have killed ourselves.
Yes.
And then it would convert, and the temperature would continue to raise as after the aluminum had been completely converted into gas.
Yes. So to start off, we have our solid phase right here. We then have our melting point, which is this little flat plateau.
And of course, you all remember exactly why it's flat like that, and we don't need to explain it at all.
At all. Yeah. And what occurs at this stage, Dan?
This is where it has completely converted to liquid from here, and the temperature continues to raise, which, as I said, we didn't have the tools to measure, so our calculations will stop there.
Absolutely. So now we will add in little snippets to help you visualize this. And we are using solid ingots of aluminum, which look pretty much like this. We now have our solid aluminum ingot, which has been turned into liquid somewhat.
Beginning to.
Yes. So we have a little pile of aluminum that's melted right here. Moving forward from that, we have full-blown liquid right here. Here, we have the start of the boiling point.
Where the liquid aluminum starts to convert into the gas phase.
Yes, which that would be dangerous. And for all intents and purposes, I don't know how to draw a boiling point, so we're going to make it very violent with all kinds of gaseous aluminum particles flying around, and woo! It's going to look something like that.
And then here, you would just have a cloud of gaseous aluminum.
Which if you breathe that in, you would die.
Yes, pretty much.
D-E-D, dead. All right.
As Dr. Carter would spell it. So this is, we've shown you what we intend to do, and we've told you that we are going to calculate the amount of energy it takes to do that. This is what you need to know to calculate the energy. We have the molar mass of aluminum.
We have the specific heat of aluminum.
The heat of fusion of aluminum.
We have the aluminum melting point.
The day's temperature.
And we also
And
have the
Kelvin.
pounds per gram.
So in order to calculate how much energy it takes to melt the aluminum, we need to know several different things. Some of it is here, and a lot of it we need to calculate. The first thing we're going to calculate is how many grams of aluminum we actually had. Our ingots that we used weighed 1.6 pounds.
Yes.
And there are 453 grams per pound. So multiplying those together comes out to
725.74 grams.
0.74 grams. The second thing we need to know is how many moles of aluminum we have. Of course, and we all know this, we haven't forgotten it all.
You better not have forgotten it.
Otherwise, you're getting an F on the next test.
Absolutely zero.
And the
okay
test
points.
we just took as well. 5.74 grams divided by the molar mass of aluminum, which is 26.98, which equals
26.89 moles.
26.89 moles. The next thing that we're going to calculate is how much energy it takes to reach the melting point. Now to do that, you first have to know how many degrees Kelvin you need to raise that piece of aluminum. Now, the day was a very hot winter day at about 80 degrees Fahrenheit, which makes it be 299.8 degrees Kelvin. The melting point of aluminum is 933 degrees Kelvin, which results in needing to raise the aluminum
633.2 Kelvin.
0.2 degrees Kelvin. Now, to find out how much energy it takes to do this, we have to use the specific heat of aluminum, which is 0.91 joules per gram Kelvin. So, 0.91 times the degrees Kelvin we must raise it, which is 633.2, 576.21 joules for 1 gram of aluminum. Now, we already calculated out how many grams of aluminum we actually have. So we take 576.21 times the grams of aluminum, which is 725.74, which equals
418,178.65.
5, which is a very large number. So we convert these joules to kilojoules, which would equal
418.18.
Calculated 418 point, what was it? 18 kilojoules. Alrighty. So that is the kilojoules it would take to raise the solid aluminum at a base temperature of 80 degrees Fahrenheit up to its melting point. Now we have to calculate how much energy it would take to convert said solid aluminum at its melting point into liquid, as of course we remember that those are two entirely separate numbers. So to do that, we take the heat of fusion of aluminum, which is 10.7 kilojoules per mole, which is joules per mole, and then we multiply it by the number of moles that we calculated earlier as 26.89. This comes out to equaling
287.72
kilojoules to convert solid aluminum at its melting point into liquid. Kilojoule of 287.72, multiply it, or add it, excuse me, to the kilojoules we calculated earlier of 418.18, which comes out to
705.90.
So this number, 705.90 kilojoules, is the amount of energy it would take to raise the solid aluminum up to its melting point and then to convert its solid form into liquid.
breathing this stuff.
Let's take a second to appreciate that advice. Yes, scientific world, here we come.
You had an air bubble. No biggie. Hopefully.
No, I mean, uh-oh, that's on the bucket.
Oh. Oh dear. Poured it a little too fast.
And there she blows!
Right, edit this bit out. Yeah, that's working much better. I think it just hit the football. And it caught on fire.
Are you still rolling?
I think I got a lot of footage of ground, but yes, I'm still rolling. I think you're gonna need a new bucket.